Hello friends, this video is on tests of statistical significance. This is an important question from the chapter Research Methodology and Biostatistics in Public Health Dentistry. What is test of significance? Consider we are conducting a study. For example, we study the efficacy of a new drug against a standard drug for a particular disease. The target population will be people suffering from the disease. We select a sample for the study. A sample is a part of the population. When different samples are drawn from the same population, the estimates might differ. This difference in estimates is called sampling variability. To know how far the difference in estimates is due to sampling variation, we use the test of significance. The first step in conducting test of significance is to state the hypothesis. What is hypothesis? It is an explanation based on known facts but not yet proved. In our example, there is no difference between the two drugs. That is, the observed difference is entirely due to sampling error and it has occurred by chance. The opposite of null hypothesis is the alternate hypothesis. This states that there is difference between the two statistics. Example, the new drug is better than the standard drug. Following the statement of hypothesis, we calculate the test statistic or T-statistic and find the p-value. Test statistic is calculated depending on the population mean, sample mean, standard deviation and sample size. P-value is the probability of observing a test statistic as extreme than observed value. We need to assess the strength of evidence against null hypothesis. It is easier to prove something false than proving something true. So it is easier to test null hypothesis. When a null hypothesis is tested, there are four possible outcomes. 1. Null hypothesis is true but our test rejects it. 2. Null hypothesis is false and our test accepts it. 3. Null hypothesis is true and our test accepts it. 4. Null hypothesis is false but our test rejects it. In this process, there are two types of errors. One, type 1 error or alpha called significance level. Alpha represents the amount of acceptable error. Rejecting null hypothesis when it is true is alpha. The value of alpha is established in the beginning of statistical analysis. The next type of error is type 2 error or beta, accepting null hypothesis when it is false. For a good test, values of alpha and beta should be small. Typically, alpha can be up to 5% and beta can be up to 20%. Alpha will be the cutoff value for p-value. Compare p-value with alpha. 1 minus alpha is called the confidence level. 1 minus beta is called the power of test. Power is the probability of rejecting null hypothesis when it is false. Power of test should be 80 to 90%. With these values, we decide whether null hypothesis should be accepted or rejected. These are the basics of tests of significance. For different situations, there are various types of tests. Basically two types, parametric and non-parametric tests. Parametric tests are applied when data is normally distributed. Examples of parametric tests are paired t-test, unpaired t-test, analysis of variance or ANOVA, Pearson's correlation coefficient. Non-parametric tests are applied when the data is not normally distributed. Examples of non-parametric tests are sign test, Mann-Whitney test, chi-square test, Spearman's correlation coefficient. These tests will be dealt in detail in future videos. Thanks for listening. Kindly subscribe our channel, like and share the video with your friends. Please give your valuable feedback about this video and do comment topics that you need videos on. Happy learning!